The pandemic equation describes the evolution of pandemics. It balances the infection rates and pandemic mitigation measures, providing a means for describing recurring waves and extracting parameters that characterize the pandemic. The pandemic equation describes pandemic waves using two timescales, slow and fast. This approach was borrowed from the quantum theory of solids. It also modifies the famous Fermi-Dirac distribution function, introducing the Fermi-Dirac special distribution function to describe the transitions between recurring pandemic waves. COVID-19 is a unique pandemic that evolves by replacing one virus variant with another. This is why COVID-19 is called an immune saboteur. This replacement of virus variants results in repeated pandemic waves. The pandemic equation describes these waves and shows how a new COVID-19 variant replaces its predecessor. Humanity has lived through many devastating pandemics, with COVID-19 being the latest but not the last. The effect of the COVID-19 epidemic on the global economy was dramatic. This is what Union Station in DC looked like when we traveled from Washington, D.C. to New York City in the winter of 2020. There were almost no passengers and people were afraid to travel. The COVID-19 infection evolves quickly, but many mitigation measures work slowly. Therefore, the pandemic equation uses slow and fast timescales to describe the mitigation effects. The pandemic equation borrows these mathematics from the quantum theory of the solid state. The solid state theory represents electronic and atomic motion by using fast and slow timescales. This approach could also describe a behemoth moving slowly but changing its motion due to mosquitoes in pursuit. By learning from the past, the pandemic equation could predict how the pandemic develops in the future. It is a valuable tool for researching and quantifying the effects of healthcare and mitigation measures. It will help humankind to better prepare for possible future pandemics and epidemics. Thank you for watching. For more information, please refer to the full paper in Encyclopedia.